Hello, this is Andy Schweitzer, and this is a little review of atomic trends. This is actually a worksheet for a little ELT review, extra learning time review, and just kind of bring everything together for practice on atomic trends of radius and ionization energy. So as we go through this thing, you can pause the video and try out a few problems. Now, here we have all of these guys, and we're just going to start by answering some questions about them. So when I'm looking for biggest to smallest, the first question says, when assessing an atom is bigger, which atom is bigger, what's the first thing we look for? And in this case, we're looking to find the energy levels. So the periodic table is going to really tell us this because for the most part, it matches up with the rows. And draw a very good periodic table here. There's an extra row there and row here. So what row is the last electron in? I'm just going to jot this out here. The aluminum is going to be in the third row. Calcium, now let's just skip calcium for a moment here, but we have neon. Neon is going to be in the second row, second row, second row. Now, I'll come back to that one in a moment too because we have an electron charge here. Barium is way down there. Let me check it out here. Looks like it's row 6, potentially. If I count right, 6. Helium is row 1, and argon is row 3. All right, now calcium typically would be in row 3. For calcium, actually row 4, but it has 2 valence electrons here for calcium, and it lost both of those with this positive 2 charge, so it got knocked down to 3. All right, and then oxygen has 6 valence electrons, 1, 2, 3, 4, 5, 6. So we gain 2 more, but we're still in the same energy levels. So we're still at 2. So the first thing to look for is the energy levels. And I have those kind of written above here. Have any atoms here lost or gained an energy level due to ionization energy? And the answer to that would be yes. Calcium. Calcium had 2 valence electrons, and it flipped to calcium plus 2, bringing it from the last electron in this guy would have been 4s2, and now it's 3p6. That's for the electron configuration. So this tells me my energy level right here. List all atoms working the same energy level and in groups. So we have, okay, so the first energy level, we have helium, and that's it. Okay. The second energy level, we have oxide, we have oxygen, that's it. The third energy level, we have argon, we have calcium plus 2, all right, so then we got calcium plus 2 is located right here. And we got aluminum is also in the third energy level. All right, fourth energy level, nothing in the fourth, fifth, nothing, but we do have this big one in the sixth energy level, which is going to be barium. All right, so when trying to discriminate between small differences in size, more protons. So in this case, within these rows, they're going to be very similar in size, and that's what we're looking at. Okay, which ones? Now, how do we separate between those? Well, more protons is always going to make you smaller, regardless. More protons. So if you're adding this, if you have the same number of protons, and electrons always make you bigger. So keep that in mind. This is 2 trends as far as that goes. All right. So with these 2 things in mind, let's list them for the next question. List the atoms in order to increasing size. Okay, so helium is going to be first. Now, oxygen versus oxide. All we did here was add 2 electrons, so it's going to be oxygen followed by oxide. All right, and then third energy level, we have argon, calcium, and aluminum. So we have argon, calcium plus 2, and then we have aluminum. All right, they're all in the same energy level. So the big difference here, they're all the same electrons, big difference is protons here. Uh, Argon has 18, calcium has, well, in this case, calcium has 20, and aluminum has only 13. So the smallest is going to be the most protons, plus 2, and then we got argon, and then we have aluminum. All right, and then just now followed by, in that case, the last one, which is barium. Did I miss any? Don't believe so. Let's see here. List atoms or increasing ionization energy. Just going to be just the opposite. It flips from that of size. All right, which atom here is the biggest? Look at energy levels. This has a 3 energy levels, so X is going to be, Y is going to be the biggest. This atom has the biggest level. This atom's biggest energy level on the biggest atom is, okay, so that would be a 3s. Biggest energy level on the biggest atom would be a 3s. That's going off the electron configuration. How many valence electrons do each one have? We have 1 valence electron, and we have 2. And finally, draw a Bohr diagram.